Well, hello, everybody, and thank you for coming. And your show and tell was fabulous. I loved it. So I'm Liz Nesbitt. I have retired from the Burke Museum at the University of Washington, and I'll show you a little bit about that. I know you had Kelsey a few months back. And I have, since I retired, we suddenly moved down to Portland. Our whole family is here, grandchildren. So it seemed very important to move to Portland. But I'm continuing to work at the Burke. So I wrote a book that some of you have seen, and I want to talk about my book. So this is not, thank you. This is not a research talk, it's a talk about the book. I had a co-author, David Williamson. I'll talk about that. And the photography, I just want to say a word for Mike Rich. The photography of the fossils in the book were all done by Mike Rich, who is a retired engineer from Boeing. And he came to the Burke, and he came and somehow somebody sent him to me, and he said he wanted to take pictures of fossils. Whoa, do I need somebody to take pictures of fossils? And so I had a lovely setup. I had bought with a grant a beautiful setup, and he started taking pictures. And if you do look at the book, you'll see his beautiful pictures. It took us 2 years, but he works only on Wednesdays from 10 to 3. So from 10 to 3 on Wednesdays for 2 years, he worked on these fossils. He was amazing because we really struggled with these fossils, and we had different backgrounds and different types. And then he'd go home and think about it and send me an email saying, what do you think about this? I don't know, you're the guy, do it. So I really want to say thank you to Mike. He was wonderful. The illustrations in the book are from these two gentlemen who are from Argentina, and the illustrations were for the exhibit. So a lot of this is about the Burke. I'm not sure if Kelsey talked to you much about the Burke, but I'm going to do that. So the Burke Museum is a natural history museum and the Museum of Culture on the University of Washington campus, but it is the Washington State Museum. It has a very complicated, difficult relationship because some of the financial lines come through the university and some of them don't. So there's always tension about what's going on. So the curators, there were 14 of us, are half-time within the Burke Museum as curators and half-time as faculty in our various departments. So I was in the geology department, and the others are spread across campus. If you ever, I know some of you get there, I just talked to somebody there, but if you go, we're up here on the very northwest corner of campus on 45th, and 45th is the exit from I-5. So it's very easy to find. There's parking there. It cost a fortune because it's the University of Washington. And this is our new building. We had a very old and ugly building, and we raised some funds and built a new building, which is absolutely spectacular. It was designed by award-winning architects, and we wanted to have something open, something wide, something that you could see. So it's 3 stories, but each story is double. So it's like 6 stories, and you can see through the whole thing. There's an open gallery that you can see right through everything. And the point of this is we decided when we were in the old building that nobody really knew what we did. We are a research institution, and we wanted people to see that. So we turned the museum inside out, and we have walls of glass that people can look in and see what we're doing. It was unnerving to begin with, but you get used to it. The offices they don't see us in the offices, but they can see us in all the work areas through all 3 floors. Because we really wanted people to see this is what we do. We don't just put up exhibits. We also had to do the exhibits, and that was difficult. You can imagine a bunch of us sitting around trying to decide on what to do and then try to agree on what to do. It took us a while. And then we had an exhibit design company from New York to put it all together. So up there, way on that side is the paleo exhibit, and you can see the dinosaurs in the front. There's a wall of ammonites, beautiful wall of ammonites. Behind at the very back are all the Ice Age mammals, mastodon, mammoth, sloth. And then this is just a picture to show you that you can see everything.
Yeah, I'm sorry to interrupt, but the Zoom audience cannot see the slides.
Ah,
They should be able to.
I'm glad you interrupted.
Yeah. Sure you. We're sharing. Share the screen, make sure it's on the presentation. Yeah. It should be working because that's what I did.
Yeah, we see what appears to be an edit view of the slide presentation, but not actually the full screen. I suspect it might be trapped as in an application window rather than just sharing the full screen.
Settings.
Yeah, I would just, yeah, there we go.
You guys see it clear now? I mean, the whole thing?
We see mammal birds and shell collections.
Yay, yay.
Yes.
Can you see?
And it's full screen?
Full enough. I see the next slide.
Okay.
No notes.
Yeah, I don't know
Yeah.
why we have the next slide there.
Yeah.
I don't want us to see that. Does anybody know how that works to just show the main one? I don't use that. The mouse does not respond very easily. That's worse. Yeah, hey, Greg, did you ever figure out how to get those speakers to work? With the microphone or something?
Yeah, we have to run a jumper to an input.
So the microphone that she has on.
Never mind, I can
is for
see.
people
They'll just
online be
get
able
to see the next slide.
Yeah, maybe can you talk?
I can try to figure it out. for
Talk
you.
louder, I can talk louder. Yeah. I can talk louder.
We can try to figure it out for next.
There's other screens that are showing under sharing. Yeah, I'm not sure why the mouse doesn't respond very well and the pad doesn't work.
And it doesn't matter if they can see the next one.
Okay.
Just, let's do it. Okay.
At least they can see the slide.
They can see the slides. So I just want to show you some of the collection spaces. We have brand new collection cabinets. They're all on rotators. You can move them up and down. And we can stick almost twice as many in the same space. All the drawers are full. You're looking at the top one, you're looking into the biology collection, and you can see all the bones in the biology collection. The bottom one is shells, and this is the bird collection. Beautiful new cabinets. The whole museum is just gorgeous. I can't move the slide.
Mouse. So, yeah. Okay,
Okay.
now we're going. So let me go back. Okay.
Perfect. And then in some of the exhibit space, we had to hang some of our collections. So a lot of the canoes are hanging because we didn't have anywhere else to put them. So the canoes are part of the exhibit. So if you haven't been there, I urge you to go. It's really an incredibly beautiful place. For me, it was exciting because I went from the basement for like 20 years to a third floor with a view of the Olympics. It was a fabulous move. And then I retired. I wanted to show you a picture of David B. Williams, my co-author. I wrote the book. I'll tell you a little more about that. And then I realized that I am an academic. The book sounded academic and I didn't want that. And I've known David for years, and he is a scientist, he's a geologist, he's a science writer, and I asked for some help. And we had a wonderful time. We had wonderful 2 years collaborating on this. So I want to say thank you to him. A little more about the book. I have worked in museums forever. I was at UC Berkeley and then at California Academy of Sciences, and then back at Berkeley and then up at the Berks. I've worked in museums forever, and I meet a lot of people, and a lot of people bring fossils in like this, and it's an exciting thing. And then of course I've taught many, many, many students, and I was often asked, is there more information? can you say more about Washington fossils? Where can I read it? There was no such thing. And I had this idea to write a book for a long time, but when you curator and you're teaching, there's just no time. So I retired. The museum opened in 2019, COVID happened, everything closed down. And it was a good exercise to be during COVID to write a book. Don't ask Mike, my husband, about it, because I think he had a difficult time with me. And then I hooked up with him. And I wanted a book for the general public. It's not an academic book. It is not a guidebook. It's a book of stories about fossils. And the stories I chose were stories that are of interest to people I have talked to through all the years. There's many stories you can tell, but these are the ones that I chose. So there's 24 stories in the book. And there's a little introduction for those of you who don't know much about geology. That was hard to get everything into a few pages. And then the beautiful illustrations. And I want to say thank you to the University of Washington Press, because they made a beautiful book. It was a lovely surprise to me when I saw it. And the other thing I decided to do, and I struggled with my editor, is I wanted to start with the organisms that people are more familiar with, the mammoths and the mastodons. So I go backwards in time. We start with the Ice Age and go back to trilobites, because a lot of people don't know what trilobites are, and you hope they've stuck it out through the 24 stories. The stories are also not only about the fossils, but the people who find them. And you will see through the book, many of our incredible fossils in Washington were found by people like you, avocational paleontologists, who were interested in the outdoors, interested in what they found, brought it to somebody and said, what the heck have I got? And it turned out to be something new and something exciting. So it's stories about the people as well. Of that, I'm going to talk about 3 of them today, because I better hurry up here. And the first one is related to my research. So I'm an invertebrate paleontologist, worked in the Cenozoic up and down the West Coast for all my time. I started off working with mollusks and never got into crabs. Crabs were way too difficult. And then into microfossils. So I've done a lot of microfossils. I was always very interested in the environment, the depositional environment, the ecology at the time, and changes in climate. So Cenozoic has been a wonderful way to study changes in climate. So this is one of the research areas, and that big page, I'm sure lots of you have seen this, endless rocks that are all gray, in a gray day with fog, and you're looking for stuff. So that's the Quinault on the outer Olympic Peninsula, Pliocene. It's on the Quinault tribal area, and we get permission. Looking at fossils. And I worked with a woman called Kathy Campbell, some of you might have heard of Kathy Campbell, who did her master's here. She was a student here, worked and then moved to California to get her PhD, and then came back to me as a curator and said, I have all these fossils. Do you want to help me put stories together? And we did. And one of the things she had found were these little calcium carbonate chunks in acres and acres and acres of sediment, of quartz sediment. Very unusual. I mean, you guys are out there, you know there's very little calcium carbonate there. It was weird. And there were also all these incredible concretions, all cement, calcium carbonate cement. So it was an intriguing idea. And I know some of you who have collected in the Lincoln Creek will recognize these fossils. The typical fossils in those areas where you get these carbonates are these clams. Leucinoma, Conchacele, which used to be Thyasira, Acrax, which is also called Solomaya, and they're still working on that one. Yoldia, and that is not my Yoldia, I didn't have one, and I got one from the internet. And for those of you who know names, there's a rock group from Finland called Yoldia. I thought that was cool. And Vesicomyes. Where you get these, they are usually clumped together. You usually get them together. You don't often get other ones with them. And they are often accompanied by these 2 snails, Lyricassus and Bathybombix. And you often get whale bones in all of these places. So there was a story there. And Kathy spent a lot of time doing isotope geochemistry. And that's something that's really changed during the time of me being a paleontologist, is the technology has just expanded and been so exciting, the things we can do with them. And so we realized that there were these areas from Oregon, from Northern Oregon, all the way up through Vancouver, where calcium carbonate and the suite of fossils were found. And I remember standing there one day on the outcrop and thinking, I've seen this before, I've seen this before. I went back to the museum and I pulled out drawers, and we have drawers and drawers and drawers of those clams from other places, from the Blakely, from the Lincoln Creek, from all sorts of different formations. And so obviously it was very widespread. So Kathy figured out that this was methane seeps, and she had worked with Jim Giddett for a while. And all of these animals were associated with the leakage of methane through the sediments. They have, the clams, I'll just go back quickly, the clams hold bacteria in their tissue, mostly in their gill tissue, bacteria and archaea that process the methane and give the food to the clam. So it's a lovely symbiotic relationship. Acarax doesn't even have a gut. It relies entirely on the bacteria within itself. And when I was an undergrad and we were learning about this, Acarax was a very primitive bivalve because it didn't have a gut. Now we know that's not true. It's modified itself to such an extent that it has to have these things. And that's what populates the methane seeps. Oh, and just go back to the whales. There's 2 chapters in here about whales, but whales are difficult. And as I was talking, the vocabulary for whales is difficult. And I decided not to talk about it today, but it's in the book. But the crabs are there. And that's where you get these incredibly beautiful crabs. And Oregon is known in the world for crab preparators. So you're not there without anybody knowing. The West Coast is an area with seeps. All those little dots are methane, modern day methane seeps off our coast in the soft sediment. That's modern day. Where the ring is are fossil seeps. So it goes from the Kesey Formation all the way up to southern Vancouver Island. And actually, some of the pictures I had were much further north on Vancouver Island. And the crabs. And what crab is this, Bruce? Is that Brachyplax? Oh, it's Polaris, okay. And this is what happens. This methane seeps up through the sediment. The methane is generated from organic matter. We think it's largely was from Eocene organic matter. And as the sediment squashes down, it pushes the lightweight methane up and it bubbles out. Where it bubbles out, there is a whole, the whole ground is covered by bacteria. And this bacteria is what everybody's feeding on. It's feeding on the methane. Closest there, the tube worms. We do have some tube worms, and then you get the deep water mussels, and then you get the clams in rings around it. And that is what a seep is all about. Those are the animals, the invertebrates that live around the seeps. The crabs crawl in and out and grab what they can. How the gastropods do it, I don't know, with so little oxygen. These areas, when methane hits the seawater, calcium carbonate is precipitated out, and they're very low oxygen areas. And that always amazes me. Low oxygen areas in cold, deep water are perfect for preserving whale fossils and bird fossils and all the various things that are found there. As you know, then the calcium carbonate precipitates out and forms these concretions, and we have hundreds of concretions that need preparing out. But that's the story of these, and now we're finding them all over the place. They occur mostly around the Pacific, so you have to have active tectonics. They're in Washington, British Columbia, Alaska, Japan, and New Zealand. And actually in Chile a little bit. So that's one story. The second story is about the Blue Lake rhino, and I know some of you know about the Blue Lake rhino. He is unique. There is only one specimen like this. He is 15.8 million years old in the Miocene. And that little circle there shows you where he was found in Blue Lake. And it is the Columbia River Basin, Columbia River basalts. So here's a picture that you probably all know about the Columbia River basalts, which flooded everything around here. And that's how we know the age of this fossil, because the Columbia River basalts have been dated many times. And you'll see changes in dates if you follow the literature. The latest date for this is what we're looking at is 15.8. So it is in the Wanapum basalts. That's the pink stuff there. And it has a lovely story. So in 1935, there were two couples who were hiking out there, and I'm not quite sure what they were doing. Blue Lake is beautiful, and they climbed up the hill, and the hill is not that easy. It's just debris from the basalt, so it's just rocks. They climbed up there, and they saw a cave. And so they climbed into the cave. And when they were in the cave, they saw fossils, teeth, some bone, and this amazing cave. And they took the fossils to, I think there was a paleobotanist at Central Washington University, and he sent them to Berkeley. And at UC Berkeley, there were a couple of vertebrate paleontologists, and they recognized it immediately as being a rhino fossils. And so they scurried up to Washington and went and had a look. They climbed into the cave, and they recognized it as an upside down rhino. It is a cast or a mold of an upside down rhino. Later on, the Burke went and made a mold and brought it, and we still have the original there. Now, as you go back, you can see it used to be secret. It used to be totally secret, but now you go there and there's arrows pointing the way. You can find out where it is. So it's kind of sad. And they called it Diceratherium, what they called it then in 1951. And they drew a picture of what the mold looked like, and then they added the little features of the rhino. Those little features of the rhino were not there, but they recognized the legs, and there was another couple of bones sticking out into the legs. And this is the story. The rhino was dead and bloated in a lake. And you can see when you go across Columbia River basalts, you often see lakes dead. You know, there's only diatomaceous earth now. And the volcano came. When volcanic material, particularly basalt, goes into water, it forms something called a pillow basalt. And if you've watched pictures of the eruptions in Hawaii, you can see when it goes into the water, it forms these little pillow things. And inside, it's usually empty. So the water hit the lake, formed the pillows, and he just happened to be one of the pillows. But he was already dead because he was very bloated. And luckily, that preserved the fossils, that preserved the few bones. So he is the only one in the world that we know of a fossil preserved in basalt lava. And I often got requests from people around the world saying, could they put this into their textbook, or could they use these pictures for their classes, because they'd never heard of anything else. So he's a pretty famous guy. That's the jaw. It is at Berkeley. It stayed at Berkeley. And that is a reconstruction of it now. They changed the name to Monoceros barbari, and the idea is, because there are lots of these in Nebraska, that the males had horns, 2 horns, and the females had no horns. Of course, you can't tell one from the other when you're there. It's just the idea. About 1.5 meters long, like a very large pig. They were everywhere. They were absolutely everywhere, these rhinos at the time. And the best picture I could find was the Mescal Formation in John Day. These beautiful pictures they have there. There's no rhino in there, but that sort of shows the environment in which this poor old Blue Lake rhino found his demise. The last talk is about Suchiosaurus rex. There is no such animal, Suchiosaurus rex, but we do have dinosaur bone, and I know you guys have one dinosaur bone too, and we have one dinosaur bone. And I'll tell you the story about it, but a whole bunch of kids somewhere in Olympia, where our state capital is, decided they wanted to make it a state dinosaur. And they gave it that name. So this is not a scientific name. This is a bunch of fifth graders. And somehow or other, they persuaded the local representatives to pass a law to say this is the state dinosaur. So it's all incorrect, but it's total fun. So he was found on Sucia Island. And Sucia Island is the northernmost island in Washington, in the Puget Sound. It's right on the Canadian border. And so there's a little arrow right there, and that's what it looks like. You can only get there by boat. There's no other way to get there. You have to have a boat. There's no ferry. You just have to get there by private boat. And it's a very unusual island because the north part of the island is Eocene non-marine, plant fossils, palm trees, gorgeous. The southern part is late Cretaceous marine, ammonites. And it is a state park, so collecting is illegal, but there is one permit that's allowed. It's given to the Burke Museum, and David Starr is the person who goes on and collects because David has his own boat. And he often takes Jim Geddes out there too. So I just want to show you there on the map what this is all about. So where the red dot is sort of where it is. The insular belt, the green belt, is the Mesozoic. The crescent basalt is the Cenozoic area. And of course, Puget Sound was cut much later. So during some tectonic upheaval that made the Olympic Mountains, these two were squashed together into this island. And then the glaciers came and cut big trenches in the middle of it. And what we have left is that weird island with two different types of things. So there's Jim. Some of you know Jim. And Sai just happened to be in the picture. I didn't have another picture of Jim. He's from Taiwan, nothing to do with the story. And here's one of the outcrops. And there's lots of beautiful ammonites there. But Jim and David were out there and they found this thing at the bottom and it was bone. And you know, you don't argue with Jim Geddes. If he says bone, it's bone. And he called us and said, somebody needs to come and collect it. So we're not going to collect it. It's too big. It is about 2 foot long. And so Burke people scrambled and they went out there, and the state park service was very good and took us out there. Saw that it was bone, and Jim thought that it was marine reptiles, because in Vancouver Island, we get the same age stuff, lots of reptiles. So a bunch of people went out to collect. They only had a very small time to collect because it's in the intertidal, like 6 hours. And luckily we have a diamond saw that's a gas-driven diamond saw, so that helped. But it still took them all 6 hours to get it out. It was very difficult to get out. Brought it home, and it was prepped, and it turned out to be a dinosaur bone. But that's all that we have. That's the top of a femur of the dinosaur. As they got it out, it broke, and so you can see the red line in the middle where they had to stick it together again. And there's a silhouette so you can see what part of the femur it was. So Brandon Peacock, the young guy there, this one, was involved in this, and he was a grad student. And I've just discovered today, he's your talker next month. He's your speaker. So he was a grad student at the time, and he was involved and he was very interested in it. But because he was a grad student, he had exams, he was a TA, had all these things. And after it was prepped, he just put it on a shelf. Nobody did anything. Chris was a supervisor, and you know, we just said, oh, that's cool. But it had no scientific interest because we didn't know what the heck it was. It's just a bone. About 8 months later, the Burke publicity people discovered we were sitting on a dinosaur bone. They got so excited that in no time, everybody knew we had a dinosaur bone and something had to be done with it. So Brandon, now it was summer, and Brandon said, I'll do it if you fund me. I'll take the bone. They made a cast of it and took it to Idaho and Montana to Jack Horner to see what it was. And it was clearly a tyrannosaurid. So all I could say, it was a tyrannosaurid. I want to interject now to say the exhibit at OMSI on the tyrannosaurids is absolutely spectacular. If you haven't seen it, you really should go. It is an amazing exhibit. Anyway, beside the point.
And this is the last week it opened.
Oh, is it? Oh, you have to go. It's fabulous. You have to fight your way through the kids, but it's just amazing. Yes.
Probably Saturday, but I'm guessing. On that, I can check.
Go there early before everybody else shows up. Really spectacular. Anyway, so Brandon decided that it was some sort of tyrannosaurus, maybe Daspletosaurus, but it is the rocks are 80 million years old. So it's way too old to be Tyrannosaurus, let alone Tyrannosaurus Rex, because Tyrannosaurus Rex is 70 to 65, and this is 80. Anyway, they wrote a paper and publicity, we got a lot of publicity from it. Many people complained because it had no scientific value, but boy, did we rake in the money from that. We got lots of donations. It was fabulous. We know that it's 80 to 81 million years old because of these beautiful fossils, and there are absolutely beautiful fossils there. We also, because paleontology has stepped up so much, we have strontium isotopes that'll give us an age, and we have paleomagnetism that'll give us an age. So we're pretty sure that we are absolutely there. It's part of the same rocks that are in Vancouver Island. But that's not all the story. So first of all, the Ray Troll shirt, because Ray, of course, got very excited about the Ray Troll shirt, but really we just have the one bone. And I want to talk about the last bit of the story because it's very interesting. How did we get a dinosaur in a deep water marine sediments that are only marine sediments? At the time, 80 million years ago, the Rocky Mountains had already been built. What we call the Laramide orogeny had built up the huge Rocky Mountains. So there was Rocky Mountains between Montana and Washington State. But this dinosaur is a land dinosaur, so he must have died on land and fallen into a river, and the river carried the carcass to the sea. We don't know how much the carcass, but at least it carried some to the sea. The rivers then would have originated on our side of the Rockies. So therefore, this dinosaur couldn't have come from Montana. He must have come from maybe Idaho, maybe British Columbia, Washington. He was a local dinosaur, we think. However, there's one more part of the story that makes it difficult. And I don't know if you've heard about the Baja BC theory, but there is this theory that parts of these Cretaceous marine rocks did not originate where they are now in British Columbia and Washington, but originated much further south. And with plate tectonics, like the San Andreas Fault, they were moved north, a long way north. So our little dinosaur could have actually come from California or Mexico. So that's it. I didn't have any books today. I just didn't carry any books, but the University of Washington Press has given you a discount if you want to order the books from them, and you just use that code and they'll give you a discount. And I'll take questions, and thank you.
Sure, there's gonna be questions, so ask away, folks.
Yeah, at the back. Yes, you can. Absolutely. I'll do it. Let's wait till after questions and then I'll come and do it. Yeah.
Questions?
I checked the Tyrannosaur exhibit at OMSI. It's open through Sunday, closes Monday next week.
The interesting thing about that exhibit, it came from Australia. Australia does not have Tyrannosaurus at all. So I'm fascinated to know how this all came together, but it's a fabulous exhibit.
You want to walk this way.
Mhm.
Chat to see, you can keep the microphone.
Oh,
on to answer
okay.
questions. For those people online, and they can hear me if I'm talking loud enough. What Greg was saying that you guys probably couldn't hear was that the display of the dinosaurs at OMSI is open through Sunday. And it's closed down on Monday to. Okay. 16 notes on chat. So some of them are probably going to be about the slide.
Mhm. So somebody needs to write a book about Oregon fossils.
I'm
Um,
curious.
In the process right now, to be honest.
Oh, great. I'm
Already in the
thrilled.
process. Yep.
I'm thrilled with that. It's a long process, let me tell you.
Oh, I believe it.
Yeah, I'm curious where the title of your book originated. Was it something that was suggested by the publisher?
No, it's actually our words. So one of the stories I didn't talk about was a whale fossil that was found up in the Northern Olympic Peninsula. And the people, particularly Carlos Peredo, who described this fossil for his PhD, talked to the local tribes and found out that there was this word for spirit whales. It's part of their stories, their culture, and so he named the fossil after spirit whale.
I am monitoring chat. If anybody online does have a question, I just read all your messages and I think we kind of got it squared away. And if you look, you can see Liz on the camera now.
Can I tell a couple stories about methane cold seeps?
Mhm.
So we do have a known methane cold seep out by Vernonia.
Mhm.
Have you been up to that one?
We just published a paper.
Oh, okay. It is so muddy. It is.
Yeah,
amazing.
no.
But they have those clams in them.
Yes, yes, and
Some of
Rock Creek also. So I don't know if you know Dave Taylor. I worked with Dave Taylor. We just published a paper.
There's also Triassic methane cold
Yes,
seeps
yes.
out in
Eastern
the
Washington.
Tukli area.
Mhm.
There's
So Dave Taylor and I were graduate students together. So-
Yeah.
So we've
Well-
done a lot of stuff over many years and he's done a lot of work out there.
I think some of you have been to one of those seeps in.
The Supli,
Yeah,
yeah.
I found a fourth one.
Oh, you did?
Yeah.
Oh, cool.
There's
Ah.
4 of them out.
So you have to have active tectonics to squash the sediments to get the stuff out. And you have to have very high organics in the sediment. So it's a combination of different things. Mostly they deepish because they have preserved better. We found in the Quinault, there are shallow seeps. We have intertidal seeps, but usually doesn't preserve very well. You know, it's all part of the geology in the long run.
The location at Rock Creek where the Bathabembics with the
Mhm.
Appers, is that possibly a cold sea?
Yes, it is.
It's gonna be,
It is.
so not just the one that's on Timber Road that we've been to.
Yeah, no, and
But Rock Creek where the cliff side is
right,
and all.
that's what you have to read our paper.
Can't wait to see that.
It's just been published.
If you need specimens for pictures,
It's done. We're done. We're published. We're done. We're moving on to the next thing.
I can't wait to see. When will that be published?
It's published.
Oh, it's already
Yeah,
out.
it's
How do
in
we find that one?
Paleo Bias. I'll have to send you a thing. It's on
Would
in
love to
Paleo
see
Bias,
that.
the Berkeley Journal.
That would be fantastic. That'd be some great reading. We've had a number of field trips to
Yeah,
that location.
and at the Vernonia Timber one is where you actually do see these chimneys, which
Yeah.
we don't have at Rock Creek.
Right.
Yeah.
A little bit off of animal fossils. Are you aware if Kennewick Man is still being stored at the Berkeley?
Oh, no. He was repatriated and buried. Yeah, repatriated quite a long time ago. Mhm.
For the people online, they were asking about Kennewick Man.
Yeah. So he was just stored at the Berk. We didn't own him. And he was repatriated. which is good. The whole thing was so controversial.
For people online, I just figured out how to change it so it's full screen for you. If there's any particular screen you want me to go back to, I can do that.
Well, I'm curious about a statement that your speaker made early in the presentation. First of all, I have zero background in paleontology. So you're speaking with a neophyte. You did say, however, that studying crabs is more difficult than working with microfossils. Why is
Oh.
that?
Well, because crabs are made up of lots of different parts, too many different parts, and each part has names, and the taxonomy of crabs is really difficult. Microfossils are easy, as long as you got a microscope. They're all just single-celled organisms, much easier.
That actually segues into a brief follow-up question. Does a knowledge of Latin help with the lexicon and taxonomy?
Sorry, just say that again. Does a knowledge?
Does a knowledge of Latin help with
Oh.
taxonomy?
Oh, absolutely. I was extremely lucky that I was forced to take Latin at high school, which I hated. And it's been so useful for the rest of my life. But there are books that help you. There are taxonomic books that'll help you wade through this. Many of the taxonomic names are unfortunately combinations of Greek and Latin, which is absolutely not correct, but people do that.
Thank you.
Were there any slides anybody wanted to see? No, that I can.
Now that you can do it. That's fine, don't worry about it.
I'll go back to the last page.
It's okay.
Ordering information. Well, I've been doing this since COVID.
So you can, when Brandon talks to you next month, he's actually a reptile paleontologist. He works in much older stuff, Permian, Triassic. He works across the Permian Triassic boundary. And I assume that's what he's going to be talking about. So dinosaurs were not something he usually does, but he's a great speaker. Okay.
Dad.
Okay, well, thank you. Let's check this. Yeah. So we have, it's all in the debris from the Missoula floods. Yeah, so that's where they are. There are older sloths in sediments. So in Eastern Washington, there are older sloths that are Pliocene, even early Miocene, but they're not whole, they're just bits of bones. The other sloths are all in the glacial debris. The sloth that the title is named after and the one that's in the exhibit was actually another wonderful story, and then I'll shut up after this. He was found at SeaTac Airport. They were putting in new lights and they were drilling, and this was 1965 or something, and they brought up some bone. One of the people there was a geologist and said, "Bone, stop drilling, stop, stop, stop. We got to call the museum." Museum came and they looked down and got some stuff out and saw that there was a lot of bone. So the company that was drilling said, "Well, let's dig it all up." And it turned out to be an entire sloth, giant sloth, an entire giant sloth. Everything was there. Unfortunately, the skull got crushed, but the rest of the bones there, and it's all on display at the Burke now, this whole entire thing. So it was very cool, very cool. Okay, I better shut up because otherwise I'll talk forever, and I'm happy to silence.
Any last questions?
What was the name that the blue lake rhino was given?
Oh, Menoceros, Menoceros, Menoceros.
All right. Thank you so very much.
Thank you.